Alright, so today we're going to talk about TCP. My name is Chan. I'm from Cisco Networking Academy, and this is our website. For more information, you can visit our website. The slides will be available in the YouTube. Alright, we'll provide a link to download it from our website. Right, so if you look at TCP compared to UDP, you have a lot more feature like the port, destination port, the sequence number, ACK number, checksum, urgent pointer, window size, and you also have a lot of flags here. Alright, so you can see there's a lot more features in TCP than in UDP. Alright, so the sequence number is the starting byte location in the server process. The acknowledgement field will contain the next sequence number the sender acknowledgement expect to receive. Then you have a sync flag, you synchronize the sequence number. The fin flag means that the sender has finished sending the data, they want to close the connection. The reset flag means that you want to reset the connection. Probably somebody press Ctrl C or Ctrl X to reset the connection. Then you have a push flag to push data to receive to the receiving process as soon as possible. You also have acknowledgement flag to acknowledge the sequence number. Then you have urgent pointer, urgent data that has been placed in the normal data stream. You also have window size. This one is the number of bytes the receiver willing to accept. And you also have urgent pointer. Alright, so in TCP you have a lot of built-in feature. Basically what you want to do is reliable delivery of data traffic. So they want to deliver the data reliably. Alright, then you have adaptive to bandwidth fluctuation, meaning that if the bandwidth are getting lesser and lesser, the TCP will adapt to the lesser bandwidth. If there's more bandwidth in the channel, end-to-end channel, it will adapt and make full use of the available bandwidth. Alright, so it's connection oriented, is fast and have a quick recovery, tested with years of experience since the 80s. Alright, people have been doing a lot of work on TCP. If there's no acknowledgement after timeout, the TCP will resend. Application layer, no need to resend. TCP will handle everything. So if you run your application run on TCP, all the error control, everything function will be taken care by TCP. Alright, you don't have to worry with it. You just issue a command, then the TCP layer will do the resending, timeout, and everything for you. Okay, it will take care of it himself. Whereas in UDP, your application layer has to take care of the timing out. Let's say in UDP, you send a packet and the receiver does not receive it, so you have to time out and do resend. The code to do the timeout and resending has to be coded by the programmer. Whereas in TCP, it's done by the TCP layer. So the application layer just issue a send. The TCP layer will take care of everything, resending. They will take care of how much to send and all that. It will be taken care by the TCP layer. So you can see over here, instead of waiting for acknowledgement, you send the first packet. While you wait for the acknowledgement, you send the next packet. While you wait for the next acknowledgement, you send the next packet. Alright, so in this case, you make the pipe full. Alright, just an analogy. While you're waiting for my lecture, you read the notes first. You're doing something like that. Okay, pipelining. So you can see over here, the forward channel, the pipe is full. The backward channel, the pipe is also full. So it really make full use of the channel, forward and backward. And bear in mind, TCP is duplex, full duplex, forward and backward direction. Okay. Alright. Okay, so to connect establishment, first you need to send a sync, all right, 1 2 3, and then the receiver will send back a sync ACK, all right. So this sequence number is with reference to the server, this sequence number is with reference to the client. Okay, so this sequence number is referencing the byte location, particular memory location in the client, and this one represent particular memory location of a server. Okay, then you send back an ACK. So this is a sync 3-segment, 3-way handshake, alright, they call it. The important thing is that the initial ACK number from the server must be random. If it's not random, there will be a security problem. Okay, there is a security problem if it's not random. Okay, it must be random, you must remember that. Okay, why do you use 3 message? Okay, there's a video in this URL, later we're going to watch it, why you need 3 packet before you establish a connection, because TCP is connection oriented. Why you need 3 packet? Later we're going to watch the YouTube link in here. Okay, I don't think I can play it on the video, okay, because of copyright reason, I don't know. Okay, so you can see here, you have a send a sync, then you get back a sync ACK from the server, then you get an ACK, then the connection established. After you get here, the connection established. Okay, so later then you can do a data transfer. So when you finish, you can close from the client, you send a FIN, then the ACK, then the server will send a FIN and the send an ACK. Okay, so the closing can be client initiated or can also be server initiated. So if it's server initiated, you will see this first. Okay, so if both way, then this is connection termination. Okay, alright, so then the next thing is a sliding window. Okay, so let's say currently the window size is 6. Alright, so this is the window size. You already send segment 4 5 6, but this 4 5 6 is not acknowledged yet. So 7 8 9 you can still send. You can still send segment 7 8 9. Okay, 10 11 12, this one you cannot send. Okay, alright, this one you cannot send. Let's say you receive this initial scenario, this one you send, this one you haven't sent. You can send as soon as possible. Okay, alright, then later on you receive an acknowledgement for segment 5. Alright, you receive an acknowledgement for segment 5. Okay, once you receive an acknowledgement, this acknowledgement is cumulative acknowledgement. Cumulative acknowledgement. So once you receive segment 5, so this one will be sent and acknowledged. This is sent, not acknowledged. So you can shift your window by 2 places. So now it's 9, isn't it? So you shift 10 and 11. So if you receive acknowledgement for segment 5, that means that you already received 4 and 5. Okay, it's cumulative acknowledgement. TCP works in such a way that until which last point you have completely received. Until which last point you have completely received. I think you are not that clear. Let me notepad. Alright. Okay. Let's say you have sent 1 2 3 4 5. Okay, and you receive. Okay, this is the client. This is the sender. It can be client and server, doesn't matter. We send 145, and the receiver receive 1 2 4 and 5. So what would the receiver do? It will send back a at what? 3, because up until segment 3 the segment is completely received. Alright, okay, clear. Then what you do, you will send back a 3. Okay, you send a 3, then the receiver will receive 3, then which one it will send back? At what? 6 at 5 plus 1. That means up to until segment 6, alright? Or you can say up until segment 2. Okay? Okay? So let's say I receiver expecting segment 3, alright? Okay? Okay, so the acknowledgement number is the cumulative acknowledgement, alright? Okay, it's until which segment the receiver have completely received. Okay, alright, so you can see here, even though it receives segment 4 and 5, it will still send a act 3. Okay, it will not send a act 4 and 5. Okay, alright. Okay, clear? Okay, let's go back to the slide. Alright, let's say okay, now 4 and 5. So let's say he has sent out another 3 segment, 7, 8, 9. So he sent out another 3 segment, 7, 8, 9. So he sent 7, 8, 9. So this one is already sent but not acknowledged. This one is you can send immediately. Okay, but up until here you cannot send anymore. Okay, so therefore they call it a sliding window. Okay, so this is TCP sliding window. Okay, so in TCP you have what you call a slow start, then you have congestion avoidance. Okay, and then when you reach the network congestion point, you have a request timeout. So once you receive a request timeout, you will RTO, you will set back your congestion window to 1. Alright, window size 1. That means you're sending 1 segment at a time. Then you're going to grow again. So this is slow start. Slow start means that you start at 1. But one thing they fail to say that fail start but fast pickup. Slow start but fast pickup. So first you send 1. You can see here send 1. Then you send 2. Then you send 4. Then you send 8, 16, 32. Okay, it's 32 lah. Okay, it doubles. Okay, doubles. Okay, every second it will double the window size until you reach this threshold. Okay, so you start at 1, then you quickly double until you reach the threshold. So once you reach the threshold, you know that this one you're about to go over already. Okay, so now you increase linearly 1, 2, 3, 4. Right? Every second you're going to increase your segment size by 1. Instead of sending 28, all right, you send 29, 30, 31. All right, each segment you increase 1 at a time until you reach the congestion point. Once you reach the congestion point, you will time out. You will time out, then you reset your window size to be 0, and you reset your threshold to be here. Okay, so this is slow start and congestion avoidance. So you see, slow start, you start with 1, but then you pick up very fast until you reaches the threshold. Alright, once you reaches the threshold, alright, if you keep doubling, cannot already, sure pecah one, sure overflow. Alright, so make sure you double until you reach the threshold, 70 or 80% or whatever. Okay, now you're going to do linear increase, 1 by 1. Okay, so this is congestion avoidance phase. Alright, this is slow start, congestion avoidance. So your congestion avoidance plus mean that each round trip time, this is not second, each round trip time, first time you go 20, let's say it's 32. Then after you finish your round trip already, 33, you send 33 segment. Then you finish your round trip, you send 34, like that, until the pipe is full. Once the pipe is full, then you have timeout, isn't it? Then you reset to here. Okay, so you can see here, so that in that way TCP will make full use of the pipe. Okay, first you send one packet, then the pipe will be fully utilized. Okay, one of the limitations of TCP is that TCP segment must arrive in order. If you send 1, 2, 3, you must receive in 1, 2, 3. Alright, not to say you must, it's preferable to receive in 1, 2, 3. If the TCP segment arrive out of order, alright, the TCP may send out a duplicate ACK. If the sender receives 3 duplicate ACK, it will think something wrong with the channel and reduce the congestion window size by half. If the congestion window size is half, the number of segments sent will be half, the effective bandwidth will be half. So this can easily happen if you load multiple WAN links together. If let's say you want to, between one source and destination, you want to have 2 links. So some TCP will go here, some TCP will go other way. Okay, so then the packet will arrive out of order. So when out of order, the TCP may think that there is a congestion. Okay, so you can see here, his slow start reaches the threshold already, A equals to 16. But then over here, he receives 3 duplicate ACK. So he received 3 duplicate ACK. Then what happened? The congestion window will become half, will become 8. You can see here, A 16, B 8. Alright. Then you can also see here, this is timeout. You can see E and 5, 10 and 5. So you receive 3 duplicate ACK, you get back okay. So let me give you another example, okay, of 3 duplicate ACK. Okay. So let's say you send, okay, here you send like this, you get ACK 3, isn't it? Then let's say you send 6 and 6. Alright, so this one receiver receive 6. Alright, what are you going to send? You're going to send back the same thing. Alright, then you send 7. Alright, it will still send back ACK. Okay, and this is duplicate ACK. If you get duplicate ACK 3 times, then it will reduce the window size. So if this can happen if you have a channel like this, new blank presentation. Okay, you can have a channel like this. Let's say insert shape lah. Okay, let's say you have like this, Control C, okay, like this. Okay, insert shape, insert okay, let's say you have a PC here and a PC here. Okay, okay, insert text. Okay, so let's say here is 100 megabits, and over here is so this is 50 megabit, and over here is 50 megabit. Alright, so we're going to do a load balancing. Okay, we're going to do a load balancing from a PC, from here, PC1, this one is a server 1. Okay, we're going to do a load balancing where some of the traffic will go here and some of the traffic will go here. Okay, so you can see here this is a faster traffic, isn't it? So some of the packet will arrive here. Okay, but then the packet that's sent here will arrive later, even though it is sent earlier. Correct? So in this case, you have a duplicate ACK. Okay, you have a duplicate ACK. So if you have a duplicate ACK, alright, so your window size will be half. So then no need to load balance lah. Okay, so load balancing is challenging for TCP. Okay, then you don't need to load balance lah, because if you load balance, the other end will think that there is a congestion. It will reduce the window size. So in the end, it boils down to nothing. Unless you can solve this problem in your network, then it should be okay. Otherwise, then it will be difficult. Okay, but you can also load balance in another different way. In the sense that like this. Let's say another PC, another server. All right. In this case, you can load balance okay, let's say you have two server. Okay, and you have two PC. This one you use for PC 1 to server 1. Okay, in this case then it's okay. Alright, that means that from here to here you use the top one, then from here to here you use the bottom one. Okay, then that will be fine. But for using the same PC one, difficult. Okay, alright. Okay, now resume slide slow. So this is duplicate act. Alright, this photo is taken from this website. Okay, so then you have a security issue. The security issue is that initial server sequence number must not be predictable, and they're using this formula. Okay, then to avoid TCP sync attack, they're using this formula with a timestamp granularity in minutes. Alright, it might be a bit difficult for some of you to understand. You can watch the YouTube link from here. It's a 1-hour lecture from MIT. Alright, so some students, when they see the video 5 minutes, they sleep. Okay, you need to have a very good endurance to watch those videos. Okay, there's a lot of research, a lot of result. There are too many details. Some are too specific, limited use. Alright, even the most general one, some of you already start to sleep. Alright, let alone the most specific one. Too hard to understand, too many things to follow through. Alright, if you look at TCP, there was 1 year I prepared about 80 slides, for TCP. I really don't know how much they can absorb. Alright, so this is the important one I highlight so I scale down already. Okay, any question, you can send us an email. The slides will be available online. Okay, thank you.